Hi friends, in this session we'll start with a fresh topic that is called valence bond theory. It is also known as VB theory, valence bond theory. In this theorem, valence bond theory was first introduced by Hitler in London and further developed by Linus Pauling and another scientist. So initially first time it introduced by this Hitler in London and followed by it discussed by Linus Pauling. Now what actually means by valence bond theory? Many a time we thought hydrogen having partially positive charge, another hydrogen having partially positive charge, then how can H2 molecule is formed? Likewise, a chlorine atom having negatively charged, another chlorine atom having negatively charged. So how can a two negative charged species comes together and gives you the very stable compound that is Cl2 molecule? So here in case we have to give the answer, valence bond give the answer about the same phenomenon. So on the basis of hydrogen, we'll start with this theorem. This is a hydrogen atom, let's assume as Ha, and this is another atom that is called as Hb. In the nucleus of A atom, there is one proton. That is, let's take example, or the nucleus of the first proton or first hydrogen is known as Na and second is Nb. Electron of the first A atom, that is called as Ea and second Eb. Once again I will discuss. The nucleus of A atom is Na, nucleus of B atom is Nb. Electron of the first atom is Ea, electron of the second atom is Eb. Here in case we have to discuss two types of forces. First, attractive force, second, repulsive force. The first, attraction, किनके बीच में attraction होगा? तो attraction होगा nucleus to its electron, means Na to Ea, nucleus of 2, that is Nb to this Eb. Second attraction, nucleus of first and electron from the second, that is NaEb, nucleus of second, that is NbEa. So there are four different kinds of attraction forces are there. Opposite to that, how many repulsion forces are there? Repulsive forces between the same charge. Electron 1 to this electron 2 means Ea का Eb के साथ repulsion and nucleus Na का Nb के साथ repulsion. So these are the two different repulsion forces are there, remaining all are the attraction. So here in case attractive forces are more as compared to this repulsive forces, and due to this reason H and H combine together and gives you a H2 molecule. This is all about your VB theory. Let's start with the theorem. Consider the two hydrogen atom A and B approaching each other having nuclei of Na and Nb and electron present in them represented by Ea and Eb. When two atoms are at the large distance from each other, there is no interactive between them, means there is no interactions. दो बहुत एक दूसरे के बहुत दूर होंगे तो interactions कुछ नहीं होगा. As those two atoms approaches together, a new attractive and repulsive forces are operated. Means बहुत दूर होंगे तो there is no interactions, पर जैसे जैसे नजदीक आते जाएंगे तो there are two types of forces. एक जैसे नजदीक आएंगे attraction force होगा, दूसरा नजदीक आएंगे तो repulsion forces भी होगा. अब how many types of attractive force and how many types of repulsive force, that we have to discuss. The attractive forces arise between this A and B atom are first, nucleus of one atom and its own electron. Nucleus of one atom and electron, its own electron. So that is Na का Ea के साथ, this one attraction, and B का Eb के साथ. Second, there are first two types of attraction. Second, nucleus of one atom and electron from the other. Means first nucleus Na, Eb, and B, Ea. That is your second two types of attraction forces. Similarly, repulsive forces are इलेक्ट्रॉन्स ऑफ टू एटम ऑब्वियसली माइनस माइनस रिपल, Ea का Eb के साथ एंड Na का Nb के साथ. So there are 4 different kinds of attraction and only 2 types of repulsion. Attractive force tends to bring these two atoms to close by each other, whereas repulsive forces tends to push them apart. अब जो ज़्यादा हो गया वो पॉसिबल होगा. अट्रैक्शन फोर्स कितने हैं? 4 different kinds of attraction है. So attraction forces overcome repulsion forces, and due to this, one H atom, though it is having a positively charged, so H plus and H plus comes together and you get H2 molecule. Experimentally, it has been found that the magnitude of new attractive force is more than a new repulsive force. मीन्स ऐसे सर आपने बोल दिया हमने मान लिया, ऐसा कैसे चलेगा? सो एक्सपेरिमेंट से भी प्रूफ हुआ है, जस्ट बिकॉज अट्रैक्शन फोर्स एंड रिपल्सिव फोर्स कैन बी मेजर्ड. सो एक्सपेरिमेंटली इट हैज बीन फाउंड दैट मैग्नीट्यूड ऑफ न्यू अट्रैक्टिव फोर्स, किस किस का अट्रैक्टिव फोर्स था? 4 डिफरेंट काइंड्स ऑफ अट्रैक्टिव फोर्स हमने देखे, Na, Ea, Nb, Eb. देयर आर 2 टाइप्स ऑफ अट्रैक्शन. दूसरे 2 कौन से थे? Na का Eb के साथ एंड Nb का Ea के साथ. सो ये बहुत ज्यादा थे एज कंपेयर टू दिस रिपल्शन. So the two new atoms approach each other and the potential energy decreases. At a particular stage, a net attractive force is balanced that the net repulsive force is. Means जितना force of attraction है और जितना force of repulsion है वो दोनों आमने सामने आ गए तो attraction force ज़्यादा मिले as compared to this repulsion. तो repulsion को तो वो balance कर ही दिया, plus excessive attraction forces थे, and the energy becomes minimized. At this stage, the hydrogen atom are said to be bonded together and form a stable molecule. So on this stage or on this node, we can say that one hydrogen comes together with another hydrogen and gives you H2 molecule. The distance between two atoms at this stage is called bond length. मीन्स कौन से डिस्टेंस पे ये मैक्सिमम मिला? एट 74 पिकोमीटर. सो 1 H एटम अनदर H एटम, इन दोनों के बीच का डिस्टेंस कितना होगा? 74 पिकोमीटर. पिकोमीटर मीन्स 10 to the power -12. द अमाउंट ऑफ एनर्जी लिबरेटेड एट दिस स्टेज इज कॉल्ड बॉन्ड एंथैल्पी. मीन्स जितनी भी एनर्जी रिलीज हुई, अट्रैक्शन फोर्सेस ज्यादा थे तो ऑब्वियसली एनर्जी रिलीज करेंगे वो. सो जितनी भी एनर्जी रिलीज हुई दैट एनर्जी इज नोन एज बॉन्ड एंथैल्पी. ये बॉन्ड एंथैल्पी किसके लिए है? बॉन्ड फॉर्मेशन करने के लिए. दिस इज बॉन्ड फॉर्मेशन एंथैल्पी इज आल्सो देयर. मींस 1 H एटम और अनदर H एटम के बीच में बॉन्ड बनाने के लिए लोएस्ट मिनिमम एनर्जी जो चाहिए वो थी 436 किलो जूल पर मोल. सो दिस इज द ग्राफ. इनिशियली दे आर टू फार, सो नो अट्रैक्शंस आर देयर. Gradually they comes together at a particular moment. अब देखिए why there is a dip over here? Just because attractive force and repulsive force दोनों यहाँ पे है. So that is optimal distance. ये distance कितना बताया हमने? 74 picometer. And this is too close to each other. That is why it is a repulsion. So this is all about your experimental graph also. Energy versus interatomic distance. सो दिस इज ऑल अबाउट योर वैलेंस बॉन्ड थियरी. 2 मार्क के अंदर या फिर मैक्सिमम 3 मार्क के अंदर पूछा जा सकता है. वंस अगेन क्या क्या चीज़ आपको ध्यान रखनी है टू गेट 2 आउट ऑफ 2. फर्स्ट यू हैव टू ड्रॉ द फिगर ऑल्सो. हाइड्रोजन एटम का सिंपल आपको 2 स्फेरिकल एटम बनाने हैं, न्यूक्लियस दिखाना है, इलेक्ट्रॉन दिखाना है, सिंपल एज दैट. एंड लास्ट में आपको ये ग्राफ भी ड्रॉ करना पड़ेगा. So without figure and without graph you don't get 2 out of 2. खाली थियरी लिख के आ जाओगे तो you get only 1.5 or half marks. कट हो जाएगा वहां पे just because you don't draw graph as well as figure. So this is all about your first session that is called as valence bond theory. valence bond theory से आगे बढ़ेंगे, नेक्स्ट डिस्कशन करेंगे ऑर्बिटल ओवरलैपिंग. तो ऑर्बिटल ओवरलैपिंग क्या है वो किस्सा समझेंगे. ऑर्बिटल ओवरलैपिंग समझना क्यों जरूरी है? जस्ट बिकॉज उसके बाद एक बड़ा सा टॉपिक स्टार्ट होने वाला है दैट इज कॉल्ड हाइब्रिडाइजेशन. सो बिफोर वी मूव ऑन टू दिस हाइब्रिडाइजेशन, ऑर्बिटल ओवरलैपिंग क्या है वो समझना ज़रूरी है. तो दिस इज ऑल अबाउट योर टुडे सेशन. थैंक यू सो मच.